How's it going, everyone? Welcome. Elier Gonzalez here. And today, well, let's take a look now at this particular the chapter 3 of this book when we are exploring is the JavaScript scope and closures, right? And the idea that or the fact that since working with variable is the most important things that we need to know how to do in our programs. So here, Carl Simpson actually write a book to describe what are the important pieces that we need to understand as we go into JavaScript. And I will argue that in any other programming language as well, which is, hey, we need to understand is not only the low level features but also everything that is around here. So that was the chapter 1 when we explore about the surroundings of JavaScript. So for example is who made this, why the name of JavaScript, who owns the legal trademarks. So now who oversees for that spec to be adequate to the demands of the industry, right? And which is a TC39 commit, and what is the role of this commit, what is the process that they do, what is the goal. And despite that we can now run JavaScript in different platforms, the only reality that matters is the web. So because the TC39 wants to provide is these features or to make now, so they don't want to break the web. Okay, so in order to do that, they now provide some polyfills in their champions or in their proposals as a way to now is if you like to live in the edge, or if you're using, for example, some transpiler, for example Babel or TypeScript, so you can use this latest syntax in your programs. And when it comes to create a JavaScript that are browser safe for the vast majority of browser out there, well, you can now target that specific and generate the specific code to that browser, to those browsers, right? So because all JavaScript environments, unfortunately, they are not, and I repeat, they are not, is the same, or they are not JavaScript spec compliant. For example, the console in the browser is just a friendly JavaScript environment, and there are some reasons about that. There's some actually observable facts that I can show you, but not in this video. And also is the concern about now if JavaScript is fast enough to write your programs, and why now JavaScript, in essence, if not in practice, is a compiled language, not in its distribution model, but is in the way of how now it analyzes the code, right? In JavaScript, we can also look at different programming paradigms that we can describe our programs, and each one of those paradigms help you to solve a specific problems that you might have in your programs. So for example, computations with functional programming, or collaborations with object-oriented programming. And also we have is this procedural, and because there also is a concern of JavaScript that is not a fast language, that has been successful attempt or precedent that describe now that this is possible. And not only that, it is that this group of developers in engineering at Mozilla, they actually showed that that was possible in 2013 with ASM.js. When they pour now an Unreal game engine into the browser at full 60 FPS, and they did that by creating a subset of JavaScript that target or that provides hints to the JavaScript engines to run optimizations. So years by, and now we have this ASM, or the assembly, web assembly, that in essence what it says is like, hey, let me now is serve as a universal compiler target, right? So we also look at what the strict mode is, which is a guide of how developers must write code to let the JavaScript engine, or for having good chance of the JavaScript engines. Jesus. The idea is that this strict mode is this set of rules that developer must follow when it comes to write their codes to give now a good chance for the JavaScript engines of optimizing and running our code, right? So this is just to the surface of JavaScript, what is around JavaScript. And then we'll look at the core of the JavaScript, right? Or the serving JavaScript. So for example, what is a program, what is a value, the type of value that we have, so primitive objects and functions, and what is now the role of functions in the language, as well as the way of how can we describe these values, whether it's as a literal or held inside of a container, aka a variable, and the different syntax forms of the variables, as well as the other places where we can define variables without being explicit about it, right? And how now these values can be compared. What does it mean comparison in JavaScript land, and what does it mean is conversion from one type to another, from one value type to another, and the way of how can we organize our code, which is whether it's for functions, classes, and ESX models. And then now looking at the deep root level of the language, which is the iterations. So what is the iterator protocol, the iterable, as well as feature that has been from the beginning of the language that are specific for the function, such as closure and the value of this, and another in a property from objects, which is the object prototype, right? Or the object prototype chains. And all of this is just to briefly describe is the synchronous nature of the language. Because when it comes to now dive into the asynchronous nature, and one of the reasons why JavaScript has been so powerful and has this particular language has stretched out a lot, because in the beginning of the computer programming, most of those programs were written to be run in the machine or on the machine. But as the year buys, and in the 60s and the 70s, where we came now is run programs, and how can we now make these different programs to communicate, all right? That's the asynchronous nature of this. Back then there were several of these techniques that emerged from that. One of them is the thunk. So for example, and I know that go beyond the scope of today's video, but I do think that it's quite interesting to at least understand that there is another area in JavaScript to look for. Now, on that, all right, and since at the end of the day, what we can do here is look now at the scope, all right, which is part of the reason why we are looking here, and the scope, and how now, and why it's so important to understand scope, especially in any programming language, because now working with variables, as I mentioned before, is the most important things that you will do in your programs. So because now these variables that held values as a container, okay, and since these variables that you defines are affected based on the function or the block scope, or even in the try catch, but in our case the block and the functions and how they relate each other, right? So variables, functions, and blocks, they are now determined. The relationship is at compile time. So this this scope structure that is not modified at runtime conditions, and because now values are because functions are values, and you can define its variables inside of a functions. So this scope structure that is defined at compile time, this structure that is defined at compile time. So anytime that you run, or whenever you call that function in any different place of your programs, it won't affect that scope, aka you are creating is a closure. So because of that, in order to understand now this compilation process happens, we went is just to describe is a little bit of the compilation and the interpretations, which is this process in which these source of text are converted into instructions that can be understood by the machine. So because we have the compilation and interpretation, that they serve as different steps to process this transformations, but they differ in the way. But they different. So the difference lies in how they do that, how they do the things. So because of that, right? And exactly. So because of that, sorry, my bad. So because of this different set of process to transform the source text into the machine readable code, we need to look at the classical theory, the classical compiler theory, just to make a case here of why it is important to understand this as a way to know this concept known as closures. So this is the reason why, by explaining is this classical compiler theory, you have these three phases. So the first is the tokenization and the lexing, where it's going to convert out a statement into meaningful tokens for the language. This is similar as when you are reading is English. So you transform this sequence of tokens, all right, into something that is meaningful for you, right? So if you read, for example, Chinese, well, if you don't understand that, exactly. Or Spanish, perhaps if you are from this English-speaking nations, you might quite maybe understand that. But the thing is that, right? So this is lexing. It's transforming now a particular statement, okay, a particular statement into meaningful tokens, right? Into meaningful tokens, uh, into meaningful for the language tokens, right? And the difference between the lexing and the token, according to him, is that lexing is when the tokenizer decide if the next token is a different or is part of the same token, right? So then you have now the parsing phase, when it's going to now collect all of these different tokens, this string token, into a syntactical grammar structure, aka into a tree data structure, which is a way of how we can represent now on the machines the structure of this of the source of text of our programs, right? So once that is done, now it converts that into the binary files, right? So this can vary depending of the language, the platform, and also the distribution. But the point of this is, by understanding this particular process and look at the observable facts from JavaScript when it comes to now is analyze syntax errors or detecting some early errors. So for example, with variables names, with parameters with the same names, among other features, and the hosting, all right, with the var and let. So because of this, JavaScript is a little bit more complex than this compiler, because it doesn't have any build step. In other words, it's going to take now this instruction and immediately try to run that. Since this is a scripting language, well, it turns out that you need, as a team who now are implementing is this JavaScript engine, go on with some hacks and stuff to try to parse that entire source of text and execute that. So this is, for example, in the case of the 8 engine that they have now, is the profiler as well as the compiler that generates some intermediary representation of the code for further refinements, and then ultimately is going to execute a program. But in any case, this observable fact that happens in our programs in JavaScript is one of the case to say, hey, JavaScript in practice, if not in essence, if not in practice, is a compiled language, not from the distribution point of view, but for how now it's processing, from how now it's analyzing the code and handles errors. So we also look at this particular stuff known as the reference, the target and the source reference, which you might wonder, hey, why do we even care about looking at this particular concept, especially on assignment? So when you want to assign something, whether it's on the left side hand or the right side hand, pretty much like an equation in 8th grade math, okay? So it turns out that this assignment, which is going to call that the target and the source, will look at different way of how can we now make an identifier or a name the target of an assignment, okay? Whether it is using a var or a let or cons. Functions declaration is another way of how you can now bind that And you can actually take a look at the ECMA script here, the ECMA script here. I'll take my word from that. When it say here's the expression, lexical grammar, source of text, executable code and execution context. Is on statements and declaration. Is the bindings, exactly. So this is what I want to do. Take a look. Binding. The operation. But I do think this is from statements and declarations. Okay, but it's not here. It's on the scope analysis. I do think it is here. No, this is a coupled records that has been created. Ordinary ECMAScript functions objects. No, source of text. Lexical grammar, expressions. Not at all. Look at this. You see this early error? This is all what I'm talking here. This is the reason why I am looking at this. So identifiers, left hand side expressions, static semantics, early errors. If a syntax error is any source text is matched by this production exists in order to prevent automatic semicolon. No, but what I'm looking here is the scope, man. Is the scope analysis. The bound name, exactly. So what I'm describing, what I'm telling here is, or what I'm saying is that because of this assignment that we're looking, bear with me, which is the way of how can we now is associate is an identifier with a reference, all right, with a value, okay. So these operations that can be now is in different forms, okay, whether it's as a binding identifier like this, whether it's a lexical declaration with let and counts, whether it's also as a variable declaration. Object is another way of how you can define this or create this, bound this to an array as well. The binding inside also is a function binding property list. So for example, as a function in the force declaration with let or cons, and how you inside of the define also is you assign this reference to a variable, similar for function declaration, and the formal parameters, which is a fancy way to say, hey, the parameters of this function. Also for array arrow parameters, generator declaration, okay, generator declaration, async generator declaration, class declarations. So for example, if you go to this and say, hey, this particular definitions class, say user, it doesn't have anything, but you can have access to the user, right? So JavaScript create this, it will not create anything, but JavaScript now associate this this name or identifier to a value here, right? And this association, as you call here, import declaration, import class, name import, and export. So all of this is just a different way of how you can now is in JavaScript um, define these variables. So these variables definitions that happen is when you use some of these declarations and the reason of understanding which is the source of the text and which is the target. All right. um, yeah, in order to understand that, which is the source of this assignment, in which is the target of this assignment. So which is something that we're gonna see right now in today's video, and also some things that are quite relevant for how you can modify even the scope structure, which you have to be careful with that. Using is the eval, so you don't want to do that in your programs. And also is the lexical. Okay, so by looking that JavaScript define the scope, the lexical scope, and the reason why we call this lexical is because of this association of this token. Hey, if this is a token, or if this is a different token, right? If the next token is now part of this token, or if this is a different token. So this lexical definitions to determine is at where is your variables defined, at which scope they are defined, which happen is in this compilation phase. It also described that this is the behaviors when you can, instead of a functions, define variables in which the scope structure is now defined at compile time. So we look at this particular example here in order to see some of this lexical exercise, you know, or AKA is the then is this. All right. So we look at this particularly example, right? Which is this. Is how we're going to illustrate is scope. So is this one, right? This is the reason why we have looked at this. So we have demonstrated that JavaScript scope is determined at compile time, right? So the term of this kind of scope is lexical scope, and lexical is associated with the lexing stage of compilation. So to narrow down this chapter down to useful conclusion, the key idea of lexical scope is that it is controlled entirely by the placement of function, block, and variables declaration. Don't take my word for that. You can actually is looking at this, right, and the scope analysis, and especially here, the syntax directed operation, which is an algorithm that, let's gonna take a look, which is an algorithm here. A syntax directed operation is a name operation whose definition consists of algorithm of each which is associated with one or more production in the ECMAScript grammars, right? So a production that has multiple alternative definition will typically have distinct algorithms for each alternative. But this syntax directed operation, which is an algorithm that produces this ECMAScript syntax, okay? In this ECMAScript syntax, right? So for example, is the runtime semantics evaluation and the scope analysis, which is the bound name, is going to produce now this list of a string, this list of bound names. Bound names based on the identifier and the reference and the value here. So this, as I mentioned before, this binding and this bounding name, or this the idea of this association with the identifier and a value, all right, whether it is, or a reference, whether it is a using is the normal traditional var or let or comes or the function definition or class or even export model or import model, okay? So it's associated with the lexing stage of compilation as discussed early in this chapter. So to narrow this chapter down to useful conclusion is that the key idea of lexical scope is that it is controlled entirely by the placement of functions, blocks, and variable declaration in relate to and in each other. This is because the examples that we look at this, right? Based on these particular examples here, right? And especially is the hosting here, is that the lexical scope, which is determined is at compile time, in the key takeaway of the key takeaway is that the functions, variables, and block, how they relate each other, this determine is the scope of those variables, of those bindings, right? Okay. So, the idea of looking at this chapter is because of that, is to, well, look at now, so observe a behavior that JavaScript describe, that JavaScript has, when it comes to now determine is the scope of a variables, and how this scope now is controlled by the placement of the function, blocks, and variable declaration relate to each other. So if you put now variables declaration inside of a function, it's going to be compiled the function and associate the so that declaration or that variable declaration inside of the function scope. So if a variable is block scope, for example, let encons, then it is associated to the nearest enclosing block scope. So furthermore, a reference of the target or result role for a variable must be resolved as coming from one of the scope that are lexically available to it. Otherwise, the variable is said to be undeclared, which results in an error. If okay, this is now by looking at the target and the source. So if a reference, which is a value, we can think of most of the time is a reference. So furthermore, a reference for a variable, whether it's the target or the source, must be resolved as coming from one of these scope that are lexically available to it. Otherwise, the variable is said to be undeclared, which usually result in an error. If the variable, if not declared in the current scope, the next outer enclosing scope will be consulted, and this process of stepping out one level out of the scoping nest continue until either a matching variable declaration can be found or the global scope is reached and there is nowhere else to go. So in other words, this is now part of this let me see if I can find that, which is this syntax direct operations, asterisk operations, syntax direct operations, static semantic, mathematical operation, value notation, and identity, algorithm conventions, and syntactic and lexical grammars. Okay. Okie dokie. But the question remains. The question remains that why do we even care about to know that this is a source, if this variable's referring is a source of a target, okay? If a reference for a variable, why do we even care if a reference for a variable, whether it's the source or the target, it is resolved at coming from the scope. Okay, so they are resolving from the scope that are lexically available to it. Otherwise, it will say undeclared, and unfortunately, this undeclared and undefined is funny behavior that the language has. When it say reference error is undeclared to that. It is important to note that the compilation doesn't actually do anything in terms of reserving memory for scope and variables. None of the program has been executed yet. Instead, compilation creates a map of all lexical scope that lay out what the program will need while it executes. And you can think of this plan as inserted code for use at runtime, which defines all the scope, aka lexical environment, and register all the identifier variables for each scope. So this lexical scope, which is not defined, for example, if you take a look now at the scope analysis, in no place here is telling you where this happen. Declaration part, hostable declaration. Static semantics. Lexical declare name. And on the other is the evaluation. So what I'm looking here is to say, so the question is this. So why um, knowing that a reference for a variable, whether it's a source of the target, is resolved at compile time and determined via its scope, okay? Why is that is relevant for us, okay? Why is that is relevant for us? Well, because this variable's reference, whether it's a target or whether it's a target or the source, is going to be determined at compile time within the lexical scope available, and if it's not there, it's gonna now next outer than closing scope will be consulted, and this process will be go on until until a match happens or the global scope is reached and there is nowhere else to go. So it is important to know that compilation doesn't actually do anything in terms of reserving memory for scopes and variables. None of this program has been executed yet. Instead, compilation creates some maps of lexical scope what the program will need while it executed. So this scope analysis, where it happened all of this, and resolve binding records, right? So all of these operations that happen is at compile time, bounding its name, declaration part, its contents, lexical, and all that kind of stuff. When we navigate to the executable code and execution context, so for example, the different execution, the executable code and the execution context. So for example, is the environment records that define the association of identifier to specific variables and functions based upon the lexical nesting structure as they describe here. Usually, an environment record is associated with some specific syntax structure of ECMAScript code, such as function declaration block and catch clause. So each time such code is evaluated, a new environment record is created to record the identifier bindings that are created by that code. But again, this is when the code is evaluated. It's going to now have these records for functions, block, and catch in the try-catch statement. Okay, and every environment record has an OuterEnv field, which is either null or a reference to an outer environment. Hola.
Hola, sí, ¿te moviste de Carrefour?
All right, and we're back. So, all of this is just to say, hey, I am not the things that I'm mentioning here is stuff that are in the ECMAScript, is in the spec, and this association of the identifier to specific variables and functions based upon the lexical nesting structure based upon is this is why this is something is not for the beginners, not for the beginners, bro, not for the beginners, not at all, definitely is not at all for that. So the association between an identifier to specific variables and functions based upon the lexical structure code is usually environment record. Okay, usually it's an environment record is associated with some specific syntax structure. Exactly. So when you now execute a function, a block, or a catch, it now create this environment records for you, and every environment record has an OuterEnv field, which is either null or a reference to an outer environment record. This is used to model the logical nesting of environment records values. The outer reference of an inner environment record if is a reference to the environment record. Exactly. The out is this. So this is used to model the logic nesting of environment record values. So they have now this reference. So the outer reference of an inner environment record is a reference to the environment record that logically surrounds the inner environment record. Okay, the outer reference of an inner environment record is a reference to the environment record that logically surrounds the inner environment record. An outer environment record may, of course, have its own outer environment records, which is this. An outer environment record may, of course, have, exactly, an outer environment record may, of course, has its own outer environment records. Its own environment records. And an environment record may serve as the outer, and an environment record may serve as the outer environment for multiple inner environment records. So for example, if a function contains two nested functions declarations, then the environment record of each of these nested functions will have their outer environment records of the current evaluation of the surrounding functions. Environment records are purely a speculation mechanism and need not correspond to any specific artifact of an ECMAScript implementation. If it is impossible for an ECMAScript program to directly access and manipulate such values. So the environment record, but it's describing is this is what it's describing is this. So the environment record is describing is now this nesting lexical scope structure that happens for certain grammars, okay, for certain specific syntactic structures, or simple functions, block, and catch. And when the code is evaluated, it creates now a new environment record. It's created to record the identifier bindings that are created by the code. And this environment's record that can be is either a function or a model or an object environment record or a global variable record. It contains now certain methods, abstract methods for that. So all environment record have this, because at the end of the day, this environment record is the association between an identifier and a name and a function or a variable here. Okay. And then you have now is the function environment record, where as you can see, this is a property of this. This is the this value used for the invocation of the function here is an ECMAScript value. The this value. Function environment record, this binding status, and function object. Function object whose invocation causes this environment records to be created. And the new target. A construct of this. If this environment record was created by the construct internal methods, new target is the new value. And also you have another associated bindings or another methods here. Bind this value, has this binding, and get this binding is defining is the series of steps in order to do this. Global environment record has binding, create binding, and the global environment records here, it has now the object record, the global this value, and the declarative record. Binding object is the global object. It contains global built-in bindings as well. Functions declaration, generators, async generator. It contains global built-in binding as well for all of this. Binding in the global code for the associated realm. And here we're talking about the realm. The realm. So, but okay, alright. So all of this is just to describe that on the scope analysis, where it defined is this abstract operations, or exactly syntax directed operations, which is how it's going to produce this grammar in the language. This algorithm that's going to produce is the grammar. Okay. And now the environment record is the combination between now these productions, or it is when this is okay. This is the reason why we're actually looking at the reference for a variable must be resolved as the coming from one of these scope, and that is because the association of an identifier to a specific variable and function is based upon the lexical nesting structure of the ECMAScript code. So it is important that to know that compilation doesn't actually do anything in terms of reserving memory for scope and variables, because this doesn't happen is at this parsing or compilation phase. This happens is at execution. At least this is how they describe here. Again, one thing is that this is what the spec says, and the other is that how it was implemented. But each time such code is evaluated, a new environment record is created. So instead, compilations create a map of all the lexical scope that lays out what the program will need while it executes. And you can think of this plan as inserted code for use at runtime, which defines all the scope, aka lexical environments. This is why we look at these environments. And lexical environments, it says that this particularly this association or the determination of the scope that happens at compile time, it is called lexical because it is this particular token, and those tokens are functions block where it's now create is in a new environment record. In other words, while the scope are identified during compilations, they are not actually created until runtime, and each scope needs to run in the next chapter. In each exactly, in each time, a scope needs to run. So we'll sketch out the conceptual fundamental for lexical scope. So here's when we look at now this particular description. I'll prefer I'll prefer here, instead of he's using is the bucket, marbles, and bubbles as a way to illustrate now the lexical scoping, okay, and how this actually it works. um, I do find that these conversations among friends is another useful metaphor to process or analyzing variables. Okay, so we use so here Kyle is using is the metaphor of buckets, marbles, and balls as a way to now is illustrate is the lexical scope, right? And how the lexical scope is defined, is affected. So, for example, when you put now so marbles are variables or identifiers, and buckets are the scopes that are now affected, right? And the other is a conversation among friends would say, hey, once you have all of this marbles and buckles there, marbles inside of all of these particular buckets, all of these scopes, right? So how is going to process this? For the process of analyzing variables and a scope, they come from is to imagine various conversations that occur inside the engine as code is processed and then executed. So we can listen in of these conversations to get a better conceptual foundation for how scope works. So let's now meet the member of a JavaScript of the JavaScript engine that will have conversation as they process our programs. Exactly, because now first is to describe the to illustrate now the lexical scope in terms of it is variable functions or the the identifiers and the identifier as marbles or variables, as well as the scope as buckets. Okay, so when we are not able to identify this, when it comes to analyzing that, so we're using as a metaphor to listen in the JavaScript engine on this conversation that happens here between the engine, the compiler, and the scope manager. Why is that? Because the scope are not determined is at compilation. They're not creating any reserve space in memory for that. It happening is at runtime. Why is that? Because of this. Okay, because of here. Here is describing is this in the environment record. Okay, so so for you to fully understand how JavaScript works, you need to begin to think like the engine and friends. So this conversation that happened is at these two phases, the parsing and then the execution. Okay, so let's go to running our program example here. So let's examine how JavaScript is going to process that program. Specifically starting with the first statement. The array and its content Exactly. Mm-hmm. So, exactly. So by first analyzing is the first statement. Here, the array and its counting are just basic JavaScript values, literals, and thus unaffected by scoping concern. So our focus here will be on the var student. Okay, let's examine how JavaScript is going to process the program, specifically starting with the first statement. The array and its counting are just basic JavaScript values literal, like this, and thus unaffected by any scoping concerns. So our focus here will be on the var student declaration and initialization assignment part. So we typically exactly the declaration and the assignment, and this is the two phases of the language: the declaration and the assignment, and then the execution, or the declaration and the assignment, and when the assignment happens and when the declaration happens. We typically think that of a single statement, but that's not how our JavaScript friend engine see it. In fact, JavaScript treats this as two distinct operations. One which compile exactly. Mm, One which compiler will handle during compilation, and the other which engine will handle during execution. Mhm. The first things compiler will do with this program is perform lexing to break it down into tokens, which it will then parse into an abstract syntax tree. Once the compiler gets to code generation, there is more detail to consider that may be obvious. A reasonable assumption will be that compiler will produce code for the first statement, such as allocate memory for a variable, labels it student, and then stick a reference to the array into that variable. But that's not the whole story. And here's the step compile will follow to handle that statement. In counting var, as you can look at this and the scope analysis here. So when it encounter, so when the JavaScript engine encounter or when the compiler encounter this var student, it say, hey, bound name is a variable declaration. Okay, it's a variable declaration, it's a variable statement here, that this variable statement declare variables that are scope to the running execution context, that are scope to the running execution context, variables environments. Var variables are created when they're containing environment record. Wait, var variables are created when their containing environment record is instantiated and are initialized to undefined when created. So within the scope of any variable environment, a common binding identifier may appear in more than one variable declaration, but those declarations collectively define only one variable. A variable defined by a variable declaration with an initializer is assigned the value of its initializer. Assignment expression: when the variable declaration is executed, not when the variable is created. Uh-huh. A variable defined by a variable declaration with an initializer is assigned it is assigned the value of its initializer. Assignment expression when the variable declaration is executed, not when the variable is created. And here is telling you this story. So a variable defined by variable declaration, which is this variable declaration between the binding identifier, that can be either an identifier or a yield or a weight, okay, and the initializer, all right, which is any assignment expression, okay. So as we read here, we say, hey, within the scope, within the scope of any variable environment, a common binding identifier may appear in more than one variable declaration, but those declarations collectively define only one variable. A variable defined by variable declaration with an initializer is assigned the value of its initializer assignment expression when the variable declaration is executed. Okay. Not when the variable is created. And there is a distinction between the execution and the creation, and especially the assignment. Assign the value of an initializer assignment expression when the variable declaration is executed. So that initializer happens is at runtime. So not when the variable is created, but it's when the variable is executed. So if we continue to read this, okay, and then we say, hey, let's examine how JavaScript is going to process the program, specifically starting from the first statement. And it turns out that the first thing that it does or is create the variable and then assign the variable at when it's executed. Exactly, when it's executed. Within the scope of any variable environment, a common binding identifier may appear in more than one variable declaration, but those declarations collectively define only one variable. But it doesn't tell here anything of the created or scope and that kind of stuff. So the first thing compiler will do with this program is perform a lexic to break it down into tokens. Okay, looking at the reference for okay. Okay, the first thing the compiler will do with this program is perform lexing to break it down into tokens, which will be then parsed into an abstract syntax tree. So once the compiler gets to code generation, there is more detail to consider that may be obvious. A reasonable assumption will be that compiler will produce code for the first statement, such as allocate memory for a variable. And the thing here is that this is not what happened. Here's a step the compiler will follow to handle that statement. It encounters var student, and the compiler will ask the scope manager to see if a variable name with an identifier student already exists for the particular scope bucket. If so, compiler will ignore this declaration and move on. Otherwise, compiler will produce code that at execution time asks scope manager to create a new variable called student in that scope bucket. And then the compiler then produce code for engine to later execute to handle the student equals to this array assignment, and the code engine run will first ask scope manager if there if they are a variable called student accessible in the current scope bucket. If it's not, the engine keeps looking elsewhere. See the nested scope below. Uh, Elsewhere. Once engine finds a variable, it assigned the reference of that array. In a conversational form, the first phase of compilation for the program might play out between compiler and scope manager like this. Compiler, hey scope manager of the global scope, I found a formal declaration for an identifier called student. Ever heard of it? The scope manager say, nope, never heard of it. Uh, so I just created for you. Mm-hmm. Compiler, hey scope manager, I found a formal declaration for an identifier called getStudentName. Ever heard of this? A formal declaration. GetStudentName for. Have you ever heard of it? Nope, but it's created in this scope. Hey scope manager of the function. Hey scope manager of the function, I found a formal parameter declaration for a student ID. Ever heard of it? No, but now it is created in the scope. Hey scope manager, I have found a reference to a student. I have found a reference to the student in a for loop that will need its own scope bucket. The conversation is a question and answer exchange where the conversation is a question and answer. The Q&A exchange where compiler asks the current scope manager if I encounter identifiers declaration that has already been encountered. If no, scope manager create the variables in that scope. If the answer is yes, then it is effectively skipped over since there is nothing more for that scope managers to do. Compiler also signals when it runs across functions or block scope so that a new scope bucket and a scope manager can be instantiated. Later, when it comes to execution of the program, the conversation will shift to engine and a scope manager. It might play out like this. Hey scope manager of the global scope, before we begin, can you look up the identifiers getStudent so I can assign these functions to it? Yep. Oh, exactly. Once now the compiler also signals when it runs across the program, across function or block scope, so that the new scope bucket and scope manager can be instantiated. Later, when it comes to execution of the code, the conversation will shift to engine and scope manager and might play out like this. Hey scope manager of the global scope, before we begin, can you look up at the identifier getStudent so I can assign so I can assign these functions to it. Okay, this value, because at the end of the day functions are values. Okay, can I assign these functions to it? Yep, here's the variable. Hey scope manager, I found a target reference for student. Okay. At runtime, this is what we care about is the reference here. But reference, exactly. Hey scope manager, I found a target reference for students. Ever heard of it? Yes, it was formally declared on this scope. Here it is. Thanks. I'm initializing students to undefined so it is ready to use. Hey scope manager of the global scope, I found target reference for next student. target reference for next student. Mm-hmm. For next student. Ever heard of it? Global global scope manager. Yes, it was formally declared for this scope. Thanks. I'm initializing the next student to undefined so that it is ready to use. Hey scope manager of the global scope. I found a source reference for get student name. Ever heard of it? A source reference. Mm-hmm. A source reference for get student name. Ever heard of it? Yes, it was formally declared for this scope. Here it is. Engine, great. The value in get student name is a function, so I'm going to execute it. Hey scope manager, now we need to instantiate the function scope. This conversation is another question and answer exchange where the engine first asks the current scope manager to look up the hosted get student name identifier so the association so to associate the function with it. Engine then process to ask scope manager about the target reference for student, the student, and so on. To review, summarize how a statement like a var student is processed is in two steps. You have now the compiler that identify is this identifier or this bind is this name. Okay, so compiler set up the declaration of the scope variable like this. So the compiler set up the declaration of the scope variables since it was previously declared in the current scope, and then is executed to process the assignment part of the statement. So compiler set up the declaration of the scope variable, and then the engine is executing and process the assignment part of the statement, and the engine asks scope manager to look up the variable, initialize it to undefined, so it is ready to use, and then assigns the array value to it. Nested scope. When it comes time to execute the get student name function, okay, when it comes to execute the get student name function, engine asks for the scope manager's instance for that function scope, and it will then process to look up the parameter student ID to assign the 73 argument value and so on. The function scope for get student name is nested inside of the global scope. So the block scope of the for loop is similarly nested inside that the function scope. Scope can be lexically nested to an arbitrary depth as the program defines. Each scope gets its own scope manager instance each time that this scope is executed, one or more times. Each scope automatically has all its identifiers registered at the start of the scope being executed. This is called variables hosted in see chapter 5. And at the beginning of the scope, if any identifier came from a function declaration, that variable is automatically initialized to its associated functions reference. And if any identifier came from the var declaration as opposed to less and cons, that variable is automatically initialized to undefined so that it can be used otherwise. The variable remains uninitialized, aka it is TDC, see chapter 5, and cannot be used until it is full redeclaration and initialization are executed. In the for let student of the student statement, student is a source reference that must be looked up But how will that lookup be handled since the scope of the function will not find such an identifier? Via the environment records. Via the environment records, bro. Via the environment record. Hey, how can now? But what? But how will that lookup be handled? Exactly. So the student is a source reference that must be looked up. Okay. On the fourth statement. Hey, this is now a reference that needs to look up. How will that lookup will be handled? Since the scope of the function will not find such an identifier. Exactly, since the scope of the function will not have such an identifier. So, because environments records are created at runtime, usually with functions declarations and functions declaration blocks. Okay, so for example here, functions declaration digi 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 Jesus this one, functions declaration. Exactly. So usually an environment record is associated with some specific syntax structure of ECMAScript code, such as functions declaration, block statement, or a catch, right? The environment records. So, because now you create now a block, and in order to resolve reference, every environment record has an OuterEnv field which might be either null or a reference to an outer environment record that is used to model the logic nested here. But it's here in the environment records. Nope, never heard of it. Try the next outer scope. Hey, scope manager for the global scope. I have a source reference. A student have exactly. The engine is asking now from the for loop or from the function, and then it goes up to the scope change. For yeah, up to the scope change to do so. So ever heard of it? They say global scope manager. Yes, it was formerly occur. If the lookup fail, all right, and this is when it's describing is it. Is the lookup fail? It will throw now a reference error that might be is why. But that it might confuse a little bit. Exactly, that it might confuse a little bit here. So the phrase not defined seems almost identical to the word undefined, but what it means is that is undeclared. Exactly, the reference error of x, y, and z. Okay, the reference errors of x, y, and z is not defined. It means that it's not declared. Exactly, it means that it's not declared. To perpetuate the confusion even further, JavaScript type of operators return the string undefined to this. It's like, hey, the variable exists, so there is a reference, but there is no value assigned to. And these two variables reference are in a very different conditions. But JavaScript surely does muddy the waters. The terminology mess is confusing and terrifying, unfortunately. Unfortunately, JavaScript developer will have to pay close attention to not mix up which kind of undefined they're dealing with, whether it's a reference error or whether it's a value undefined, whether it's a scope, whether it's a compile time or an execution time. And the other is a global what. Because if you assign here, it's also going to be appended to the global. Accidental global variable here. So it's going to look up now for the scope for that, and then assign that. Assignment to undeclared variable. Oops, an accidental global variable. It's a building on metaphor. To visualize the scope next as resolution, I prefer yet another metaphor. Exactly, because this is the three metaphors that we have looked so far in order to first illustrate the lexical scope with marble buckets, and the other is that now how those are analyzed via this conversation that happened is between the engine and the compiler with the scope manager. Okay, first with the compiler and the scope manager to determine it is identifier, the name of these functions or variables. Okay, and then the association of that the association of the values to those identifiers, to those variables. And the other is to visualize the metaphor of the scope resolution, right? Which is like chaining up, right? Using the lexical scope until there is no one else to find them. It's like a building here. You get into this until the top, and if you don't find that reference, well, it's not here. And continue the conversation. By this point, you should be developing richer mental model for what scope is and how the JavaScript engines determine and use it from your code. So that'll be all for this video. Take care. Bye bye.